Thank you for coming. My name is Michal Hrusecky. I'm from Touris, and I will be talking about how we are monitoring attackers on the internet. But first thing, I will start with a little bit longer introduction of who are we, what is Touris, and how we got to the point that we are making routers and monitoring attackers and stuff like that. I actually start with a different company. Who is CZNIC? That's actually us. We have two names. Our name is Touris. We are a branch of CZNIC. CZNIC is Czech top-level domain registry. But in our bylaws, it says that we are to be run as a non-profit, and every money that we get from the domains, we are supposed to spend on helping the world, and in particular, helping the internet to get better. And we do that via public education, but also we are developing a lot of open source software. One thing that you might know is BERT, Internet Routing Daemon, that's powering most of the exchange points around the world. But we also develop other interesting software that might be even of some use for you, like not DNS. That's an authoritative DNS server that is the fastest one around, and it's used, for example, by DENIC. And we also develop not DNS resolver. That's the counterpart to the authoritative server. So if you want to resolve your DNS queries in a creative way, you can use this open source software to help you do that. And what's most important for my story about how we started making routers is that CZNIC also runs Czech National CSIRT team. That's a national team responsible for taking care of security, so they are receiving reports, doing security research, and stuff like that. So how did we start it? It started with this CSIRT team, and they had one big question. How safe are the home users from the network attacks? Because back in the day when we started, almost every ISP was giving away public IPv4s to everybody at home, and some of them are still doing it today because they have plenty of IPv4s. And the question was, if you are running a server and you are trying to attract attention because you are advertising everywhere that this is your cool blog and people should go there and read it, and you are trying to get everybody there, it's obvious that people will start attacking you. But if you are a home user, just minding your own business and getting online, will the attackers find you? Will they try to attack you? That was the question. And how much will they try to attack you? And what they will try to do? So that's how Touris project was born. Our original idea was to make a security probe that we could deploy at people's home and try to find out what's going on and whether there is some attacks happening and what kind of attacks and stuff like that. And to be able to collect this data, we had to figure out a way how to make it appealing to people so they would want to use it. They would want to deploy it, contribute the data back. Some people would really love to help us with security research, and the idea of catching attackers and making it hard for them is appealing. But to get a more broader audience, we decided that we should make it more interesting. And basically to get the data, we had to be the first device at the home, the one with the public IP. So we needed to make it a gateway anyway. It had to support NAT because, yeah, IPv4. And people would need to like to install it and keep it running. So we decided to make it into a router. And first router was born. That was back in 2013. We made this device, gave it away for free in Czech Republic. And the only condition was that people will use it as their main connectivity point. It will be the first device at home, the one with public IP. And they will allow us to spy on them. Well, not actually on them, but on the people coming from outside and trying to sneak into their homes. We also had some statistics about the traffic, anonymized, but so we were a little bit spying on them as well. But the main data that we were after was the attacks from the outside. It contained some early version of our security research software, and it monitored traffic and reported something. Like we developed some first version of our honeypots that we have even till today. And what we were really interested was firewall logs, because we couldn't develop honeypots for every protocol. That is simply impossible. There is too much protocols. But what we could do is collect the firewall logs and see what ports are being scanned, and based on that decide what services might be interesting to develop honeypots for. Back in the days, we also collected some anonymized NetFlow characteristics, because we were interested in whether people have IPv6 and whether they are starting to use it and stuff like that. And even back in the day, we started with a centrally controlled blacklist of the attackers that we have found. And since we are this CZNIC company that really loves open source, when we were making this router, we decided from the get-go that we need to have enough resources to do wire services, because we were just starting to develop this system and we didn't know what future will bring. So we didn't know how many honeypots we will need, what other ideas will come up and would be useful. So we needed to have enough resources to grow. And because we were changing stuff and we were planning to develop it, we made it also mandatory for people to use automatic updates. So, and also since we were doing it as a part of security research program, well, without updates there is no security. So we made it mandatory and make it sure that there were automatic updates and that they worked. Because we are a DNS company, we also we didn't make it mandatory, but we made it default to use DNSSEC. We didn't make it mandatory because quite some ISPs broke DNSSEC back in the days. It's better now. And yeah, because we are open source company, we were spying on the people, so we made it open source, so they can check what data we are collecting. We gave people root accounts, so they could see that only those services are really running. They could check what we are doing and make sure that we are not doing anything fishy. And over the time, we added some more benefits. So yeah, I don't have to tell you that being open source is the right way to go. I guess being here means that you already know it, that there is no other way than open source way. But yeah, it was easier to get started. We have plenty of software to integrate, and people could do whatever they want and even contribute back. There are some disadvantages to being too open. So we have plenty of software that we can integrate, and people want everything. They favorite text editor that just 3 people in the world are using, so we are the worst guys because we don't have that and stuff like that. And as we gave people root accounts and gave them all the sources and everything, they can become really creative in shooting themselves and in breaking the router. And it's always your fault, right? Because you gave them a gun. They shoot themselves, but you were the one who gave them the gun. So yeah, thanks to that, we were not in control of all the dependencies. We depended on some open source projects, so we have to migrate from time to time to something else. But yeah, it's a lot of fun to solve these problems, and it rewards being open and open source. And because of that, actually, we ended up in retail and started selling the routers, because when we created these probes, people started playing with that and started loving those devices and started loving doing crazy stuff with them. And we got real feedback that from various conferences that people want it, not only in Czech Republic, but even abroad, want to have routers that are open, up to date, and can play with it. So we made some campaign and started doing retail. Briefly, some features. We are using OpenWRT. We have our own web user interface, and one of the coolest thing when we went to retail 8 years ago was that we integrated ButterFS. Back then it was the coolest kit in town. Nowadays they are cooler. BKFS. But we are still using ButterFS. And we are heavily relying on snapshots, because it's really cool if you have a router and you can log in and you know that you just came back from the social event on the conference and you want to try some crazy idea that somebody talked to you about. So if you are still conscious enough and cautious enough, you will create a snapshot before starting to fiddle with things. And in the morning, when you wake up and nothing works, you can roll back to the previous working snapshot and then inspect what you did last night wrong and how to do it correctly. So having snapshots is a really great thing. Also, one of the cool features that we did was you can do a snapshot and set a timer, and if you don't commit, if you don't say that everything is okay, the router will automatically roll back and reboot. That's really helpful if you are managing a router for your family that's living a few hundred kilometers away, so you don't cut yourself off. Okay, I skip OpenVPN, but one more thing that I wanted to talk about is, and that's not obvious, but might be interesting in this conference, is we are actually trying to not just lose the money, but also make some money to make it sustainable. And we actually make most money from B2B customers. And being open source actually helped a lot in that regard. we found out that being open source is a great advertisement. It has several advantages, like because being open source and geeky stuff, we are really popular with geeks. So we have men inside the company, and that man inside is really excited about everything and loves to talk to people about all the technology stuff. So they can help us. And with us being open source and doing all the development in the open, you don't need NDA, you don't need SDK, you don't need any lawyers to try your idea. And that actually lowers the bar of the entry. And we had a customer that came to us after having actually doing successful POC, because basically somebody had our router at home, he bring it to work. When they were discussing new idea, they did a POC, they didn't need anything from us because everything was publicly available. They didn't have to involve the lawyers. And yeah, lawyers came back, they had to be involved at some moment, but at the moment when they have already everything solved and everything ready. So it pays off being open source and open, because it makes it easier for people to find you, use you, and work with you. And even nowadays, those people in this company that we work with, they told me that they are watching our GitLab, seeing what we are doing, and basically being few steps behind us and waiting for us to make the path for them. So let's go back to the security research program. Nowadays it's called Tourist Sentinel. And since we went our way to the retail, nowadays it's opt-in because privacy reasons. Basically, we are running honeypots on your devices. We are collecting data from the firewall, from firewall logs from the outside. But those data, even though they shouldn't be sensitive, it still could be, because quite often it happens that somebody forgets that he has a honeypot running on their router. They try to log in from the outside, are surprised that their password no longer works and it looks kind of different than our usual web interface, that they get a little bit scared, enter their password a few times, then realize that they were in the honeypot, and then they write us. So we need their agreement that they are aware that there's this danger. How our honeypots work? We have 4 of them: HTTP, Telnet, SMTP, and FTP. All 4 of them simulate the service and only ask for the credentials. For HTTP is basic out. For Telnet it's asking for credentials, same as FTP, SMTP. And they refuse to let you in. But in the background, they are just happily collecting the IP address and all the credentials that you give them. Apart from that, we have firewall logs from the outside. So whoever is trying to scan your ports, we know about that. And we actually have another thing. We have SSH honeypot. But to be on the secure side, we are not running SSH honeypot directly on the device, because SSH honeypot is a little bit more complex thing. So we don't want to risk anything. What we run on the device is man-in-the-middle proxy. So we are opening SSH port there, and when attacker comes in and logs in, we will let him in. But we will forward him to CZNIX servers that are running the SSH honeypot, and SSH honeypot actually runs in our data center behind our firewalls. So there is no danger for the end users and their routers. and at the same time we get the complete session that we can later share with the user. And we are using all this data to create dynamic firewall. It works like that. The attacker tries to attack some of our routers. We notice him because the routers are in real time reporting all the activity that they get. And when we decide that somebody was bad enough, we warn all our routers and they will block him. So if you are running some services behind our router, these attackers wouldn't even get a chance to try brute forcing your service or trying to find some vulnerabilities. So that's how it works. Now let's take a look at the data that we collected. This is for 2024. Basically, it's actually February 2004 till February 2025. And those are the countries that we had the most attackers from. If you take a look at the list, there's actually Germany on the 11th place. I had to make it a little bit longer so I could include you. And I actually have a new guy in our team that studied statistics, and the first thing that he told us that this map is wrong. And why is it wrong? It's pretty obvious. You see that the most attackers come from India, China, United States. Those are big countries with a lot of people. So it doesn't mean that Chinese people are bad or Indians are bad. It just means that there is a lot of people there. So he actually fixed the map, and I can show you how it looks now. It's it made you disappear from the list because you also have a lot of people in Germany. Basically, he made it relative to number of internet users in the country from some global statistics. And yeah, now you see that the most evil countries are Hong Kong, Seychelles, Ireland, Namibia, probably because there's not many internet users in Namibia. And actually Germany is on 40th place, so you dropped from 11th to 40th. So you are not that bad. And one thing that I wanted to talk about a little bit more is, and that's dear to our company, is IPv6. I will be taking a look at data from only from the honeypots, from our minimal honeypots. I would disregard the firewall logs and the real honeypot, and I would like to compare behavior of attackers on IPv4 and IPv6. We will be looking at the first half of 2025, and for the purposes of the statistics, I use /64 as a counterpart to one IPv4 address because it doesn't make sense to think about anything more specific than /64 in IPv6. And yeah, we have slightly biased data because we know that only about 1/3 of our routers are getting updates on IPv6, so 2/3 of our router don't have IPv6 connectivity. So we will get more data for IPv4. And one funny point, I don't know how far you are with IPv6, but in the Czech Republic, there has been publicly announced the end date for IPv4, and that's 6th of 6, 2032, and that's when government services should stop working on IPv4. We will see what happens at that day, but it was publicly announced that this will happen, so hopefully it will scare some ISPs to implement IPv6. So first thing that I did was take a look at incidents per protocol. Incident is somebody trying to log in. I don't count individual IP addresses, so it could be attacker that is trying to, if he's trying to log in 100 times, I will count him as 100 incidents. And you can see that there is much more incidents than, it's not the third, the IPv6 incidents. But you also can see that there are different patterns in the protocols. On IPv4, the most used one is SMTP, and the second most used one is Telnet. But on IPv6, looks like the attackers prefer HTTP and don't want to try send emails over IPv6. And Telnet is also not that interesting for them. So yeah, looks like IPv6 attackers are preferring modern technologies, surprisingly. Okay, I said that, yeah, IPv6 incidents are 0.026% of all attacks. And yeah, I said roughly a third of our routers have IPv6, so it's much smaller number than just the percentage of people that have access to IPv6. But let's take a look at if we just filter it per IP address and take a look at how many unique IP addresses we will get. And let's see how much it will behave depending on the different size of the network. Basically, what I was trying to find out is in IPv6, as in the beginning I said that it doesn't make sense to take a look at anything smaller than /64. But I was wondering whether it makes sense to, whether people are getting /56 or /48. And how does it compare to /24 in IPv4 world? And if you take a look at the numbers, there is a slight drop between 64 and 56, but not that prominent. With /48, it gets down a little bit more, but it gets really down with /32. And with IPv4, we get really down even with /24. So /24 is more on par with /32 than with /48 in terms of attacks. Okay, I made it also per individual protocols. And when I was doing that, I was thinking, well, yeah, it's nice to have subnets, but for the internet, we have something else. We have ASNs, automatic segments. So instead of taking a look at the subnets that are purely technical, I could take a look at AS numbers and take a look how many AS numbers I will get, how many different AS numbers I will get. And then it gets like this. So you can see that in total I got 170 different AS numbers for half a year for IPv6. So yeah, from overlook, there's not that much going on IPv6. Well, luckily for us. Unfortunately for the statistics, because yeah, there was 29 AS numbers that were trying to do something on Telnet over the IPv6. But you can see that basically almost every attacker tried HTTP on IPv6. Almost all AS numbers tried a HTTP attack. It's less obvious on IPv4. You can see that there are much less AS numbers for SMTP, but there was the SMTP was the most incidents that we got. So for SMTP, there is probably more tries. Yeah, for AS numbers, we got similar numbers for Telnet and HTTP in IPv4. We were wondering who's behind the attacks and who's attacking. So I took a look at the biggest AS numbers. Well, at AS numbers of where the most attackers come from. And yeah, so this is what I end up with for IPv4. The first one is some Indian ISP, China Telecom, China Unicom, another Chunghwa Telecom. So for the first four IS numbers, I've got ISPs. So yeah, probably somebody somewhere connected to the internet. Doesn't seem malicious per se as the company. Looks more like a generic public. Somebody got infected. Then I have DigitalOcean and Cloudflare. Yeah, I don't blame DigitalOcean. I believe that given that they are selling the servers, some of their customers are either got attacked and hacked and abused, or some of their customers actually tried something fishy. But when we were looking at the data from time to time, we sometimes see huge activity from one IP address, and it lasts just a few days. And when we go after it, we see that there's some VPS provider or somebody where VPS started doing something bad. They received abuse report and they killed it. So those guys are actually working good to keep it out from the internet. And even though we didn't have that much different AS numbers on IPv6, I tried to look up what these companies are, from where the IPv6 attacks are coming from, and take a look. It's some hosting provider, some ISPs, and at the end there is a Facebook. And all those hosting providers and ISPs have one thing in common, and that's they are from Germany. So looks like your IPv6 deployment is good. One more funny number that I tried. I was trying to figure out whether the attackers are trying to go after one victim, or whether they are trying to do some widespread attacks. It looked kind of similar on IPv4 and IPv6. On average, they attack 13 victims. On IPv4, I get maximum of 1,500 of victims for one attacker. For IPv6, the most I got was 200. And also, I was trying to figure out something that I called neediness. That's how many times attacker and victim pair would interact. So if attacker will find some victim, how many times he will try to get in before he gives up. And yeah, there can be seen that the IPv4 attackers are a little bit more persistent and trying harder to get in. So, some preliminary conclusion. If you want to be safer, drop IPv4. But Germans can attack you even over IPv6, so be aware of them. And check out some other statistics. And I will actually, I'm not ending yet. I will just switch to live demo, hopefully. Okay, if I figure out how. Yes. So this is our public webpage where we show some statistics. You can see that's the wrong map. It shows the total number of incidents, but you can see the statistics over the time. You can see top countries that incidents came from this week. And you can also see, because the attackers are more than happy to show us their credentials and enter their credentials into our honeypots, you can see the most popular passwords. We don't share a full list of passwords because, as I said, sometimes you enter by accident your own passwords. So we show only the top passwords. Some of them you would guess. Sometimes it's harder. But yeah, if you take a look, for example, on this one, it's kind of graphic on the keyboard. So, and sometimes we see spike of really surprising passwords, and we take a look at that. One time there was a really huge spike of a password that looked randomly generated. We took a look at that, and we found out that it's default password for some Chinese doorbell. They randomly generated it. It was completely random. Then they went and put same password on every doorbell. And they put the password in the manual, in the PDF, and made the PDF available online. But sometimes those passwords can be also a good sign of something going on. A few weeks ago, our colleagues from the CSIT team, they discovered that there was some pattern and that it looked like they were related to some institution. So they contacted the institution and started working on how to mitigate the attack because it looked like somebody was targeting them. So if you want to know how safe is your password, we have a password checker. You can enter your password and send it to us. No, I'm kidding. Basically, it's developed after and modeled after Have I Been Pwned. If you don't know how it works, basically JavaScript on that website computes a hash of your password, sends us just a part of that hash. Then we, from our database, we send back all the hashes that we found. And again, JavaScript on this web page tries to find your hash in those hashes that we send in the response to the partial hash. So basically, all we know is part of the hash of your password. We don't know your password, but you can know whether attackers are already trying it actively. What might be also interesting is some port statistics. You can see those are the data from the firewall logs. So 5353 is zeroconf. So that's most likely not an attack, but somebody misconfiguring the router, and it's probably common misconfiguration. And if you put your router in your LAN network with its one port, zeroconf sends a lot of packets trying to discover the neighbors, and they break on the firewall. But yeah, there is HTTPS. This thing, I believe, is Samba. So yeah, it might be interesting. And one other thing that we have there is our dynamic firewall. As I was saying, we are compiling in real time some firewall, and this is the real-time data. Those are the attacks that are happening right now. That's what our routers are sending us, and that's a current list of block list IP addresses, and here you can see the updates to the firewall that we do. For every red line, we are adding new attacker when we discover somebody new that's starting behaving badly. But we also remove people relatively fast when they start to behave. That's because, as I said, as we saw, most source of our attacks are either ISP networks, where we can expect that the IP address could be dynamic and could change over the time, or some hosting providers where when they get rid of the problem, the IP address should be able to continue to be used. So we are also removing the attackers. And by the way, this web page is publicly available, and you can browse it if you want. And you can check your passwords, see what's trendy now. And we also have a gray list that is basically nightly snapshots of these attackers. So if you want to do some statistics or some research on top of that, we'll be happy. And now I need to figure out where I was. Here. Yeah, this is the address of the website. Okay, so future of the Sentinel. We definitely want to develop more traps, more honeypots, publish more findings. As I said, I have a new colleague that is that actually understands statistics, and so he's looking at the data and trying to figure out new ways to find something interesting, something presentable, something that will be generally understandable, and maybe we would like to do some deployment outside of our routers. Dynamic firewall is really easy. We have a client that will manage either your IP set or list in NF tables. It's open source. You can use it. The data are Creative Commons non-commercial, so it's possible to use it for your own server. If you want to do business around it, we want to be part of it. And collecting data is harder. One question that I frequently got when we are talking about this program is, hey, I want to contribute my attackers. And there's one hidden danger, and that is if we open it up completely, nothing is stopping from bad actors to register 100 accounts and sending us fake data to basically make the system unusable and not working. So currently our approach is to limit the possibility to run this program to people who bought our routers, because there's some bar. And you probably wouldn't buy 1,000 routers just to game our system. And if you do, we will figure out how to go around it. But we will have money to do that. One thing that I just learned coming here is that. I don't know if you noticed, but there is a CI cert booth in the Mensa, and one of the news on their website is that they are nowadays supporting OpenID Connect. So it might be a way how to get worldwide verified identity and let people register to our software and contribute us their data and deploy it on your servers, because yeah, we want to have data that we can at least somehow trust. And yeah, so you wouldn't just send us 1,000 times your competitors' IPs from thousands of accounts. And yeah, apart from that, we are also working on a new router that we will be releasing later this year. So if you are lucky enough to have fiber and fast fiber, which I heard that it's not that common yet in Germany, you might be interested in that. And I will be at Mensa area at our booth for some time as well. So if you have any additional questions or comments, come to see me. Otherwise, we have a Mastodon, and we have various websites, even GitLab with all our sources. Thank you for your attention, and if you have some questions, let's talk.
So, has anyone got a question? I don't see any questions. Over there and back there. So let's get started with you.
So full understanding, you cannot allow any one of us to contribute those blacklists. Are they open for reading?
The blacklists are open for reading under Creative Commons non-commercial. Okay. Share alike by CC by NC SA.
For consuming to our own blacklist, protecting our own services, because
yeah, for your personal protection, you can consume the blacklist on our website. They are marked as gray list, because yeah, you shouldn't. Well, if you are running some service like SMTP, you shouldn't directly block them. You should use them as a gray list and maybe come back later, because it might not be 100% accurate, because yeah, sometimes it happened to us that we got a lot of attacks on one IP address on one of the routers, and it was because of the misconfiguration, because the guy configured some service to be running on his router, and then he forgot about it, shut the firewall, and everybody who was trying to communicate with his SMTP at home got on our blacklist. So
MX is a totally different business anyway, so fine.
Yeah, but apart from the consuming the gray list that we have on our website, as I said, there is an open source client that you can compile and get real-time updates, so you don't have to do it with a cron job. Okay?
I mean, this list is automatically generated according to fixed rules. That sounds like non-copyrightable data to me, so how can you even have a license on it?
That's a question to our lawyers. I have no idea. Basically, the rules are not really fixed. We tweak them from time to time. We have some license agreement with the users that are providing with the data. I have no idea. I asked our lawyers, can I publish it? And they said, yes, what license? I said, this one. And after quite some discussions, we came up that, okay, this one.
Okay, so we got a question in the last row. Can you hand over the microphone, please? No voice, I think. It's loud enough for the stream. Okay.
I have tried. Thanks for your talk, but how many routers per day are sending logs to you, and how many log servers do you need on your side? And is the traffic encrypted?
traffic is encrypted. Basically, every one of our routers has some key that can be used to authenticate against our services, and at the beginning they negotiate a new key for session, and those keys are rotated every few weeks. So data are encrypted. How many logs? I've shown some numbers, but they were for half a year of the incidents. And how many routers? It differs, but roughly several thousand routers are sending us those data.
Servers do you need to get
on the blacklist?
No, on your side that receives the logs from the routers.
How many? I'm not sure.
How many log servers in your data center do you need to receive the logs from the thousands of routers?
Currently, we are fine with how many servers do we need to receive the data. Currently, we have just one server that is receiving the data, because we have a backup server in place, so we can switch if it gets too demanding. But so far, one server is fine. There is a pipeline of microservices that the data go through, so we can scale out if there will be some bottleneck somewhere. So receiving data is really simple, because basically you just need to get rid of encryption and send the data forward to the pipeline, and then it splits into multiple pipelines and do some other stuff. And this doesn't have to be on one server. We currently have, I think, 2. But yeah, so far it's kind of efficient, and there are some databases that are on other servers as well. There's Mike coming.
What happens if your own infrastructure or one of these routers themselves gets onto your list? Do you still serve security updates to routers that land on the list?
We have a whitelist in place, and that whitelists our services that are needed to distribute updates. And you can also configure on the router directly whitelist of your IP addresses that you trust. For example, if you have your server that you are connecting from to your home router regularly, you want to have it on the whitelist just in case if something goes wrong.
It was more about an idea to attack your infrastructure. Like pretending to be a tourist router and getting the infrastructure IPs that receive the logs or that serve the security updates on the block list or something? Or is there a global exception or something?
Well, as I was mentioning previously to the previous question, there is always a handshake between the router and the server with the secret that we got that was burned in the factory and it's not obtainable. There's some OTP, and so you cannot easily pretend to be a router unless you have a router. If you have a router, you can pretend to be a router, but then being one router doesn't mean that much, because, as I said, we have thousands of routers. So if one router starts sending us false data, we can deal with that. But if you pretend to, that's back to the question of why we don't allow public sign-up, because one router we can deal with. But if you pretend to be 1,000 routers, then you are given significant weight. So that's how we are trying to avoid this problem of being gamed.
Do you send automated abuse reports to ASN operators, or is there some way to get notified by you if I operate an ASN and some of my clients are doing what looks like an attack from your side?
We ourselves don't send that, but I believe and hope that our CSIT teams are looking in the data and sending not automated reports, but are looking at what's going on and sending abuse reports.
Thanks.
So not everything, but some of that gets handled.
Okay. Do we have any more questions? Otherwise, please give a warm applause to our speaker and enjoy FrOSCon.